Hello everyone, I am Aftab Alam, Maths faculty in Motion Education. So today we are going to start indefinite integration, which is very important for JEE. So first of all, I will discuss here what is called integration. Then I will come to the point why it is called indefinite integration. So actually, integration is the reverse process of integration is the reverse process. Integration is the reverse process of differentiation. Reverse process of differentiation. So this is important here. Reverse process of differentiation. Integration is the reverse process of differentiation. That's why it is called. That's why it is also called antiderivative. Antiderivative, or you can say integral. Or you can say integral, or one more name is there which is very important, primitive. Sometimes questions can be asked what is the primitive of cos x or sin x in this way. So you need to remember this primitive. Primitive means integral. Okay, so this is also name means antiderivative, or you can say integral, or you can say primitive. Now suppose we are going to consider a function a small f of x plus c. Okay, and derivative of this means d by dx, or you can say after differentiating of this function a small f of x plus c, we are getting here capital F of x. Okay, now tell me, if you integrate this function means integration of capital F of x dx will be this one, a small f of x plus c. Why this is like, see this here. Actually, what is integration? Integration is the reverse process of differentiation. So we are going to consider a function. Okay, and after differentiating this function we are getting capital F of x. Okay, so what is the integration of this? We'll get this one. How? It's very simple. Actually, you can understand in this way, derivative of sin x is cos x. So what is the integration of cos x? Sin x. In the same way, but how it comes? See this here. We know that this is movable here, so I am writing d of a small f of x plus c. A small f of x plus c, and here you can write capital F of x dx. It will multiply here. Okay, so d of f of x plus c equals to f of x dx. Now integrating both sides. After integrating both sides, you will get this same result. Okay, now here, what is this? Capital F of x dx. Okay, and a small f of x. Now see this here. This is called sign of integration. Sign of integration. Sign of integration. Okay, what is called? Whatever we are going to integrate the function, that function is called integrand. So this is called integrand. Capital F of x is integrand here, and this one is dx. Dx is with respect to x. With respect to x. This is very important to write. Don't forget to write. Why? Because actually it is showing that this function is going to be integrated with respect to x. That's why we need to write this one. This is very important. So with respect to x. Now what is this? After integrating any function, whatever we are getting the answer, that answer is called integral. So this is a small f of x is integral, or you can say antiderivative. Or you can say primitive also. Primitive. Okay, so sometimes questions can be asked what is the primitive of sin x or cos x in this way. So no need to get confused. Primitive is also same, means integral, or you can say antiderivative or primitive. Okay, now what is c here? C is very important here. C is actually constant of integration. Constant of integration. Constant of integration. Okay, now this c can be any constant. Can be any constant. Can be any constant, and the value of c the value of c, the question is that why it is called indefinite integration. So we can say that the value of c actually, the value of c is indefinite. That's why it is called indefinite integration. Okay, so this is very, very important about this is basic nomenclature of indefinite integration. Now we are going to discuss some important notes here. So first point, if a function capital F of x is there, okay, capital F of x dx, after integrating this function we are getting a small f of x plus c. Okay, so this integration geometrically represents a family of curves whose tangent at the same x are parallel and having slope capital F of x. Okay, so see this, what is the meaning of this? Means this one, suppose we are going to consider a function capital F of x dx. After integrating this function we are getting a small f of x plus c. This integration geometrically represents a family of curve whose tangent at the same x are parallel and having slope f of x. So what is the meaning of this? I am going to explain with example. Now see this here. What is the integration of 2x dx? Integration of 2x dx is, we know that x square, okay, plus c. This c is very, very important to write here. Why? You can't say x square. This c can take different value. How? I am going to explain. So if I will ask you what is the graph of integration of 2x dx, so you can't say x square. Okay, so see this. First of all, I am taking here what is the differentiation of x square. Differentiation of x square is 2x. Again I am asking what is the differentiation of x square plus 1. So you can say 2x. Again same thing, d by dx upon dx of x square plus 2. You can say 2x. Again I am asking d by dx of x square plus x square minus 1 equals to 2x. So see this here. Differentiation of x square 2x, differentiation of x square plus 1 2x, differentiation of x square plus 2 2x, differentiation of x square minus 1 equals to 2x. So what is this? c is taking here 0, here 1, here 2, here minus 1. Means this c is taking different value, and after differentiating this function we are getting this. Okay, so you can't say graph of this function is directly x square. How? See this here. What is the graph of x square? What is the graph of x square? This is the graph of y equals to x square. Okay, now see this. What is the graph of x square plus 1? So we need to shift 1 unit above the x axis. So it will be like this. Y equals to x square plus 1. What is the graph of x square plus 2? We need to shift 2 unit above the x axis. So graph will be like this. Y equals to x square plus 2. Okay, now I am asking what is the graph of x square minus 1. So again same, we need to shift 1 unit below the x axis. Okay, so it will be like this. Y equals to x square minus 1. Now see this here. What if I am taking a particular point here, x equals to a here I am taking a small a. So this one is x equals to a. This line is x equals to a, x equals to a. Now see this here. If I will draw a tangent on this curve y equals to x square minus 1, so what will be the tangent of this? Tangent will be here, like this. What is the tangent of this y equals to x square? Tangent will be this. What is the tangent of this y equals to x square plus 1? This one. Okay, and tangent of y equals to x square plus 2, this. Okay, now see this here. Tangent is here. So what is the tangent? Dy by dx. So what is the derivative of this x square minus 1? You will get here 2x, but at x equals to a, because I have taken here particular point x equals to a, so this will be 2a. Here again derivative of this x square 2x at x equals to a, so 2a. Here 2x derivative of this one at x equals to a, so we will get here 2a. Here same as it is 2a. So see this here, integration of this one, this equals to represents geometrically represents a family of curves whose tangent at the same x, at x equals to a are parallel. Yes, parallel. Okay, and having slope f of x. Now see this here. So what is the, if someone will ask you what is the graph of 2x, integration of 2x, okay, so you can't say graph of integral of 2x dx equals to, you can't say x square. You need to say here what it represents family of curve. How see this one? X square plus 1, so x square plus g. This c is taking different value for different curves. 0 here, c is taking here, 1 is c is taking here, c is taking 2 here, minus 1. Okay, so it represents this integral of 2x dx represents a family of curve. Okay, now so what is the tangent here? Tangent is dy by dx equals to 2x, but at x equals to a, so what you will get? 2a. All are equal here. Okay, so I hope you are getting these all the things here. Means integration of 2x dx, if someone will ask you what is the graph of this, so you can't say x square. Okay, it represents a family of curve. Why? Because this c is constant, so it will take different value. It will take 1000, 500, 10, 9, anything it can take. Okay, point number 2. If integrand is discontinuous, that does not mean, if integrand is discontinuous, that does not mean integral will be discontinuous. Integral will be discontinuous. What is the meaning of this series here? We know that suppose I am going to consider a capital f of x dx function, okay, and after integrating this function we are getting a small f of x plus c. Okay, now see this here. We know that this is integrand, this f of x is integrand, and this is integral. Our answer is always integral. Okay, now see this here. What is the statement? If integrand is discontinuous, okay, that does not mean integral will be discontinuous. So I am taking example here. I will explain with example. See this here. What is the integral of 1 upon x raised to the power 1 by 3 dx? So we know that x raised to the power 1 by 3. We can write in this way, x raised to the power minus 1 by 3. Okay, and we know that the formula x raised to the power n dx. What is the integral of this one? X raised to the power n plus 1 divided by n plus 1 plus c. In the same way, here we write this one. So x raised to the power here minus 1 by 3 plus 1, here plus 1 divided minus 1 by 3 plus 1. So we will get here x raised to the power 2 by 3 whole divided by 2 by 3 plus c. This is the integration of this. Okay, if you take in numerator, then you will get x raised to the power minus 1 by 3, and we know that the integration of x raised to the power n is x raised to the power n plus 1 divided by n plus 1. So we will get here x raised to the power 2 by 3 whole divided by 2 by 3 plus c. Now see this. Actually this function is discontinuous at x equals to 0. This function is continuous at x equals to 0. How? See this here. Actually this function is discontinuous. Why? Because if you put here x equals to 0, so 1 upon 0 undefined. Okay, so this function will not define at x equals to 0. That's why this is discontinuous at x equals to 0. But here this function is continuous. If you put 0, so answer will be 0. So this is continuous at x equals to 0. So now this statement is clear. If integrand, this one is integrand, is discontinuous, yes, discontinuous, that does not mean integral will be discontinuous. See this, integrand is discontinuous, but our answer is, means our integral is here, we are getting continuous. So this statement, I hope it is clear. Next, point number third. Point number third, integration of a periodic function. Point number third, integration of a periodic function. Integration of a periodic function need not to be a periodic. Integration of a periodic function need not to be a periodic. What is the meaning of this? See this here. I am going to take example here. Okay. Tell me what is the integration of cos x plus 1. Okay. Cos x plus 1 dx. What is the integration of this? So we know that cos x integration sin x plus what is the integration of 1? X plus c. Okay, now see this here. This is periodic function or not? Yes, cos x is a periodic function with period 2. Why this is a periodic function? Because we know that this cos x repeats after every 2 pi interval. That's why it is a periodic function. Periodic function with period 2 pi. Okay, and now tell me cos x plus 1 is periodic or not? Yes, cos x plus 1. Why? Because this is the concept of periodic, means when if a function is periodic and after that whatever we are going to add or subtract, means function will be periodic, there is no effect. Okay, so here after adding function will be same as it is. So this one is periodic function with period 2 pi. Okay, now what about this? This one is non-periodic. You can say not periodic. This is not periodic. Why this is not periodic? Because we know that sin x is same as it is. This is a periodic function. How? Because sin x repeats after every 2 pi interval. That's why period of this one is 2 pi. So this is a periodic. This is periodic. But this one means algebraic terms are not periodic. Like x square, x cube, or you can say x raised to power 4, 1 by x. Okay, period for this is not possible. Okay, so this one is non-periodic. So finally we are getting this one is, our answer is not periodic. So this statement read once, integration of a periodic function need not to be a periodic. Okay, so see this here, whatever this one is a periodic function, after integrating this function we are getting non-periodic. So this statement also clear, integration of a periodic function need not to be a periodic. Okay, so I hope you are getting this. Next point is, actually tell me one thing, what is the graph of here sin x plus 1, sin x plus x? What is the graph of sin x plus, if I am asking here graph of sin x plus x? So sin x plus 1, sin x plus x series, this one is y equals to x. This is the graph y equals to x. This is the line y equals to x. Now we need to draw sin x plus x. So simple. See on this line sin x graph in this way. Okay. Now see this here. This is the point here. This is the point pi. This is the point here 2 pi. Okay. This is point here 3 pi. Okay, now this is here minus pi, this one is here minus 2 pi. Now see this here, this one is actually here, this one is pi by 2, pi by 2. Now see this here, how it is. Actually this is the graph, this graph is sin x plus x, sin x plus x. Now see this here, If you put here pi, so y equals to pi, so pi means you will get here x value pi, so pi plus sine pi is 0 and 0 plus pi, so you will get here pi. Put here 2 pi, so x equals to 2 pi, and here sine 2 pi, 2 pi is 0, okay, so 0 plus 2 pi, 3 pi, in this way minus pi, sine minus pi 0 plus minus pi, so minus pi, in the same way minus 2 pi, okay, and this one is pi by 2 you will get here. So this is the graph of sine x plus x. Okay, so our next point is suppose a function capital F of x dx is there. We have a function, point number 4, we have a function capital F of x dx, okay, and after integrating this function we are getting a small f of x plus c, okay. Now see this here, if capital F of x dx is continuous at x equals to a, that means this small f of x is differentiable at x equals to a. What is the meaning of this? See this here. We know that this is capital F of x is integrand, and this one is integral, or you can say antiderivative, or you can say primitive integral. Now see this here, actually it is saying, this statement is saying that if this integrand is continuous at x equals to a, that means f of x means this integral will be differentiable at x equals to a. What is the meaning of this? Simple, if you differentiate this function then you will get capital F of x, so obvious this function will be differentiable, okay. So if suppose here capital F of a plus equals to capital F of a minus, okay, then we can say that means derivative of this function, okay, for differentiable, derivative of this function f dash a plus equals to f dash a minus, okay. So in this way this is complete. I think I hope you are getting these all the things here. Means if integrand is continuous at x equals to a, that means this one answer, or you can say integral will be differentiable at x equals to a.